Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 2 for this week, and we're going to be talking about the hurricane season forecast from Colorado State University, and these are the folks that have been doing this since the mid-80s. Dr. William Gray was renowned for starting this process and took a look at a whole bunch of variables and found correlations between those variables and how active the season was. And then Dr. Gray passed away several years ago, and Philip Klotzbach, who was a graduate student under Bill Gray, more or less took over the reins. But it's quite a team out there. They've got a lot of graduate students that are working on all sorts of different things related to tropical meteorology. So very, very impressive group. So I just wanted to share some things with you, and so I'm going to put myself down here in the corner. And I'm going to talk about first something called accumulated cyclone energy. And the acronym for that is ACE. You knew there had to be one, right? And so this is a way to measure the overall intensity of a hurricane season. And the way this variable works is that we know the kinetic energy is proportional to the velocity squared. Okay, it's mv squared, if I'm remembering correctly. And so the amount of energy in the storm is going to be proportional to the square of the speed, maximum sustained wind speed, whatever it happens to be. And they take this every 6 hours. Now, so you take the max sustained winds every 6 hours within a storm, once it becomes a named storm, you square that number, okay? And then you divide by 10,000. And the reason you do that is that when you square these higher wind speeds, you get some pretty big numbers. And so dividing it by 10,000 simply brings it down to a reasonable value. Okay, it doesn't change the meaning at all. It just gives us a more workable number. Then you add all the values up every 6 hours for a given storm, and that gives you the accumulated cyclone energy for that storm. And then you add up all the storms, and you end up with a total number for the season. And the total, of course, is the accumulated cyclone energy. Now, one thing I wanted to point out, and there's often some banter back and forth on social media and so forth about the fact that, oh, the hurricane season is, or Hurricane Center is hyping these wind speeds that nobody actually ever observes winds that strong. Well, there's a reason for that, is that when they talk about the maximum sustained wind, it can be anywhere in that circulation. Of course, it's likely to be in the eye wall itself. But the chance of that patch where that maximum wind speed is being, observed by the reconnaissance aircraft, the chance of that going over top of an observing station is about as close to zero as you can get, okay? So it shouldn't be surprising at all that when you take a look at the coastal weather stations, that rarely do they report a sustained wind speed as high as the Hurricane Center advisory is saying that the maximum sustained wind speed is, because people think of that and they say, oh, all the way around the center, the max winds are 120 miles an hour. Not even close to that, okay? It's on a relatively small part of that circulation. The rest of it can still be very significant, but it may not be quite up to that number. And so again, the chance of those small pockets where those wind speeds exist going over top of a weather station taking observations is very small, so there's nothing inconsistent about what's going on there at all. So can we please trash that conspiracy theory? Okay. All right. So here are the accumulated cyclone energy values since 1960. And what I did here, and by the way, I had to go through 29,000 lines of data in Excel to come up with some of these graphs, which was fun in sort of a weird way. But what I did here was I took a 10-year running average, and so you don't see this little dotted green line here moving until 1969, because it takes from 60 to 69 to get 10 years to start off. So you can see that there was a decline as we headed toward the mid and late 70s and on into the early 80s, and sort of stayed that way until the early 90s. And then there was a notable increase from the early 1990s up until the early 2000s. But since that time, we haven't seen that line continuing to go up like that. In fact, if anything, it's trended downward just a little bit since the early 2000s. So there's no indication here that we are, continuing this upward trend that started back in the early 1990s, okay? at least with respect to ACE, okay, the accumulated cyclone energy. Now, let's take a look at the number of hurricanes each season, starting in 1960. And again, I'm taking a look at a 10-year running average. And again, you can see a slight decline here going into the early 1990s. You see that same increase into the early 2000s, then it levels off. And most of the time since then, the running 10-year average is a little bit lower than it was back in here. So a very similar trend to what we saw with the ACE values. Now, with the number of major hurricanes, you can see that, again, fairly low in here, and then a marked increase from the early 90s up into the early 2000s. Then it levels off, and then, again, the overall trend is slightly downward after that period of time. Now, the red line here represents the 30-year climatological average, which is 3.2 major hurricanes per season. So you can certainly see that in here, all the numbers or all the values were lower than the climatological average, and then we've had a lot that have been above that climatological average since that point in time. So you can sort of look at this in a number of different ways, but the bottom line is once we had this increase up to here, okay, it's sort of leveled off, okay, and we haven't seen this, like these peaks continuing to go up like this. Okay, now what I did, and this was the one that took 29,000 lines of data to look at, is that I went back through all the storms going back to 1960 and just arbitrarily said, let's take a look at what the lowest pressure was for any given season. And I set 930 millibars as a threshold. Just for a frame of reference, Hurricane Hugo, I believe, was 935 at landfall. So we're basically looking at that intensity and stronger. Now, you can see that there are a number of years. I mean, you'll have, a couple in a row and then a break and a couple and then a break and so forth. And the one that really stood out was in 1988. The low pressure with Hurricane Gilbert was 888 millibars. And then in 2005, Hurricane Wilma that hit Florida in October got all the way down to 882 millibars, okay? So there have been very, very strong hurricanes, going all the way back to 1960 and of course long before that. Now the only thing that's interesting here is that toward the end, we have 5 consecutive years, a 1-year break, and then last year we also had pressures as low as 930 millibars and lower. So there has been, more consistency or more consecutive years with low pressures in here than we see at any other point in the record. Now, does 5 to 7 years make a long-term trend? No, of course not. Okay, so we'd have to wait and see whether or not we have like 10 more years of seasons with pressures of 930 millibars or lower for us to be able to, wake up and say, something may be going on here, okay? But at least for right now, this is only a trend over the last 7 years, and we simply need more time. In fact, the reason that 30-year periods are used for the normal, the 30-year average temperature, is that it's generally assumed that you need to look at least the 30-year period to establish any real climatic trend, okay? And so 7 years clearly does not qualify for that, all right? So what does all this mean in terms of what Colorado State is saying for a forecast for this season? Well, we had the El Nino, a strong El Nino this past winter, but it is already transitioning, and all indications are we're going to head into a La Nina later this summer and on into the fall. And La Ninas are not nearly as inhibiting for Atlantic hurricanes as an El Nino is. And so based on that, the folks at Colorado State are predicting a very, very active hurricane season. So here are the actual numbers. The 1991 to 2020 average in terms of the number of named storms is 14.4. They're forecasting 23. In terms of named storm days, the average is 69.4. They're going for 115. In terms of the number of hurricanes, the long-term average is 7.2. They're going for 11. 45 hurricane days compared to the average of 27. Major hurricanes, 5, with the average being 3.2, and major hurricane days almost double the average, 13 compared to 7.4. Accumulated cyclone energy, 210 compared to the 1991 to 20 average of 123. Not quite double, but pretty darn close. And the accumulated cyclone energy west of 60 degrees west longitude, which would put the East Coast in play, 125 compared to the long-term average of 73. And they are also indicating that the probability of a major hurricane making landfall along the east coast of the United States is significantly higher than normal. Now, the one thing I will point out, I think there is probably less skill in terms of predicting landfall locations than there is the total number of storms. And I have always tried to preach the fact that you can have an active hurricane season in terms of the number of named storms, but the important thing is, where do they go? And do they hit populated areas and cause, a copious amount of damage? In 1992, Hurricane Andrew, which was one of only, 4 Category 5s to ever hit the United States, occurred in a quote-unquote below normal year. There were only 6 named storms that year, and the normal would be, 14.4. And so the number of storms doesn't really tell you anything. The important thing is where they go and whether or not they hit populated areas. You could have 20 hurricanes out in the middle of the Atlantic, and all they're going to do is give fish panic attacks. Or you could have one Category 4 or Category 5 hit a populated area along the Gulf Coast or the East Coast, and don't tell anybody in those areas it was a below normal season because they've been devastated by this powerful hurricane that has hit their area. So I certainly don't want to discount this. I think the chance of it being an above normal season in terms of the number of storms is a reasonable way to go, okay? But I'm just saying that I don't think we are at the point yet where we can say it's a guaranteed disaster for someplace along the East Coast. It could happen, okay? But I don't think we're at the point in the science to be able to say something like that is definitively and as a guarantee. There's no question, the more dominoes you have out there, the better chance that one of them's going to fall on you. And that's just basic statistics. But again, this is something that we're simply going to have to watch. And the peak of the season really doesn't get going until the middle of August and then continues on into late September. And there have been some very strong hurricanes in October. Wilma in 2005 hitting Florida, one of the examples of that. So it looks like we're going to have a lot to watch as we head toward this hurricane season of 2024. There are the credits. That is bonus weather video number 2 for this week. Number 3 will be coming up on Friday, and of course the next daily weather update coming up tomorrow. So you all have a great rest of your evening. If you don't see this till tomorrow morning, have a very good Thursday, and we'll talk to you later on Thursday afternoon. Take care, everybody.